This is a trigonometry review, part 1. Let xy be a point associated with a real number t, measured along the circumference of the unit circle. A unit circle is a circle with radius 1 from the point 1, 0. So we're given a circle. So notice here we have the point 1, 0, and we're following 1, 0 up until we get to the ordered pair xy, and notice we go in the counterclockwise direction. So this distance is going to be t. And now we're going to look at the trigonometric functions. The first one is sine, and it turns out that sine of t is equal to y. The second one is cosine, and we have cosine of t is equal to x. And so it turns out we could represent that ordered pair xy as cosine t sine of t, just like this. Now, tangent of t is equal to y divided by x. Cosecant, well, cosecant t, written this way, is equal to 1 over y, and that's where y doesn't equal 0. Secant t is 1 over x, and that's again where x is not equal to 0. And by the way, when I call tangent of t y over x, I also have to assume x can't be 0. And then for cotangent, I'm going to write cotangent of t is equal to x over y, where y doesn't equal 0. Okay, now let's take a look at tangent of t. Now, tangent of t is equal to y over x. But we've already established that y equals sine of t and x equals cosine t. Therefore, I'm going to replace y with sine t and x with cosine t. And I get tangent of t is sine t divided by cosine t. So this is a very useful relationship for us. Now, cosecant t is 1 over y. But remember that y is sine of t. Therefore, I'm going to replace y with sine t, and we get cosecant of t is 1 divided by sine of t. And secant t is 1 over x. But remember that x is cosine t. And so, therefore, if I replace x with cosine t, I get secant t is 1 divided by cosine of t. And lastly, we get cotangent of t is x over y. But again, remember that x is cosine t and y is sine t. So if I plug those in, I'm going to see that cotangent of t is cosine t divided by sine t. And one more thing I'd like to point out is this. Cotangent of t is equal to x over y, which is the same as 1 divided by y over x. But if you remember back here, y over x is the same as tangent of t. And so I can say that cotangent of t is 1 divided by tangent of t. Now, let's look at the equation of a unit circle. So we know that x squared plus y squared equals 1. But remember that x is cosine t and y is equal to sine t. And this is one thing I love about the unit circle, because I could directly substitute those values in, and we immediately got the Pythagorean identity for, well, I'll just say one of the Pythagorean identities. So cosine squared t plus sine squared t, here, let me write that a little better. This is equal to 1. Okay, so this is the first Pythagorean identity that we absolutely must know forwards and backwards. Now, start with cosine squared t plus sine squared t equals 1. And what we're going to do is we're going to divide both sides by cosine squared t. And that means I divide everything by cosine squared t. And when I'm finished, I get my second Pythagorean identity. So I get 1 plus sine squared t over cosine squared t. That's going to be tangent squared t. That's on the left side. And on the right side, 1 over cosine squared t turns into secant squared t. And this is the second Pythagorean identity we need to be familiar with. Now, once again, start with cosine squared t plus sine squared t equals 1. And I'm going to divide both sides by sine squared t. So cosine squared t divided by sine squared t plus sine squared t divided by sine squared t. This is equal to 1 over sine squared t. And so cotangent squared t plus 1 is equal to cosecant squared t. And this is the third and final Pythagorean identity. Now, let's talk about this. A function f of x is even if f of negative x is the same as f of x. Okay? A function f of x is odd if f of negative x is the same as negative f of x. Now, how does that relate to sines and cosines? Well, let's take a look. So I'm going to draw a picture. Here's y, here's x, right? And then we have a unit circle. And remember that this is the point xy, which is equal to cosine t sine t. Okay? Now, remember that that ordered pair xy is associated with that real number t. So remember that that's the distance from 1, 0 up to that point xy. And we're going in the counterclockwise direction, which is indicating that t is going to be positive. Now, if we go in the clockwise direction, so let's suppose we follow that point down. Now, this point is going to correspond to x negative y. So notice the x didn't change, but the y did. And if I followed that point 1, 0 down to x negative y, I claim that's going to correspond to negative t. Now, cosine of t is equal to x. Cosine of negative t is also x. And so what that tells me is that cosine of negative t is the same as cosine of t. All right? And it doesn't matter, I claim it doesn't matter what t is. T can be any real number. And what does that mean? Well, what that tells me is cosine is an even function. Now, if we take a look at sine, so notice how sine t is y. Sine of negative t turns into negative y. But remember that y is sine of t. So I'm going to replace y with sine t. And so this is negative sine t. And so what that tells me is that sine of negative t is negative sine t. And again, I claim it doesn't matter what t is. This is going to hold true. And what that says is, let's go back. That says that sine is an odd function. Now, we can use the fact that sine is an odd function and cosine is an even function to determine whether tangent is an even or odd function. And so what do we do there? If we take a look at tangent of negative t, are we in agreement that this is sine of negative t divided by cosine of negative t? But remember that sine is an odd function. So this is negative sine t. Cosine is an even function, so I could write this as cosine of t. But remember that sine t over cosine t is equal to tangent t with that extra negative. And so this is negative tangent t. And so what that tells me is that tangent of negative t is the same as negative tangent t. And that says that tangent is an odd function. And you could do something similar with secants, cosecants, cotangents. It all works in much the same way. And by the way, this is everywhere where the tangent is defined. So, in other words, we can't deal with t equals pi over 2 because cosine of pi over 2 is 0 and we can't divide by 0. Okay? Now, I'll do one more for this review. So like if we have cosecant of negative t. So this is 1 over sine of negative t. But we rely on the fact that we know that sine is an odd function. And so this is 1 over negative sine t. But remember that 1 over sine t is cosecant t, and we still have that extra negative. So I could write this as negative cosecant t. And so what that says is cosecant of negative t is negative cosecant t. And what that then tells me is cosecant is an odd function. So they all work like that. Okay? Now, I want to describe a relationship here. We know sine of a plus b is equal to sine a cosine b plus sine of b cosine of a. Okay? Now, let's suppose I let a equal b. Then what I get is sine of a plus a. But that's sine of a, so I'm going to replace b with a, so I get cosine of a plus sine of a cosine of a. But a plus a is 2a, so we get sine of 2a on the left-hand side. And on the right-hand side, notice how those terms look alike? And that just says there's two of them. So we get sine of 2a is 2 sine a cosine a. And so I want to give you a little bit of insight into how I think, okay? I tend to remember this top formula. This is just something I've used for many years. And then I go, okay, if I forget the double angle identity, just let a and b be the same thing, right? Because you're trying to look for 2 times an angle. And then this is what we get down below. And we could do the same thing for cosine. So like we know cosine of a plus b is cosine a cosine b. We go minus sine a sine b. And then once again, I'm going to let a equal b. And so then I get cosine of a plus a. But this is cosine a cosine of a minus sine a sine of a. And so a plus a is 2a. So we get cosine of 2a is cosine squared a minus sine squared a. Now, this is one of the identities for the double angle formula for cosine, okay? Now, we're going to start with cosine of 2a. And what we're going to do is we're going to replace cosine squared a with 1 minus sine squared a. So I'm going to write 1 minus sine squared a here. So that's the same thing as cosine squared a. And then I'm going to subtract sine squared a. But this is 1 minus 2 sine squared a. Now, there's going to be occasions where one version is more preferable to the other. But if you remember one, you could get the 2 others free of charge. And so what this says is cosine of 2a is 1 minus 2 sine squared a. Okay? And again, we're going to start here with cosine 2a is cosine squared a minus sine squared a. And I'm going to replace sine squared a with 1 minus cosine squared a. But what you want to do is you want to distribute the negative in, and you get cosine squared a minus 1 plus cosine squared a, which is equal to 2 cosine squared a minus 1. And so cosine 2a is 2 cosine squared a minus 1. And those are the 3 versions of the double angle formula for cosine. Okay? Now, let's talk about this and this. And in both cases, what I want to do is I want to solve for, in the first one, I want to solve for sine squared a. And the second one, I want to solve for cosine squared A. Now, if we have cosine 2A is 1 minus 2 sine squared A. And so I'm going to subtract 1 on both sides. And I'm going to get cosine 2A minus 1 is negative 2 sine squared A. Now, divide both sides by negative 2. And so I get sine squared A is cosine 2A minus 1 divided by negative 2. But if you don't mind, I'm going to multiply numerator and denominator by negative 1. And I'm going to say sine squared A is 1 minus cosine 2A divided by 2. So you notice all I did is multiply numerator and denominator by negative 1. It's just like multiplying by 1. And so that just changes the sign of everything. This formula is very useful. Very useful. Oh, let's go back. In Math 401, or I'll put in parentheses Calc 2. This is a very useful formula. I think of it like a power reducing formula. It's very useful when you have to take an integral. Okay? Now, let's take a look at this last one for this video. If I have cosine 2A, I get 2 cosine squared A minus 1. So I'm going to add 1 to both sides, and I get 1 plus cosine 2A is equal to 2 cosine squared A. But if I divide both sides by 2, I get cosine squared A is 1 plus cosine 2A divided by 2. And that's going to conclude this video for, well, this could be for any type of calculus class, or it's a trigonometry review. And we'll call this Trigonometry Review Part 1. Okay, thank you.